Hi dear children, I am teacher Geeta. This is grade 11 physics portion electric field. This is the continuation of a previous video, Coulomb's law. In this lesson we are discussing about electric field strength, then electric potential, comparing electric and magnetic field, then uniform electric field. What do you mean by electric field? And what about its direction? Electric field is the region in which an electric charge experiences a force. The line indicates the direction of the force a charge would experience. In the picture also you can see that the electric field line due to an isolated positive charge would radiate outwards uniformly in all directions, and the electric field line due to an isolated negative charge would radiate inwards uniformly in all direction. With this away from the positive charges towards the negative charge. Here also showing the, see that arrowhead, this is outwards and here it is inwards. And these two pictures, that one the electric field direction of positive point radially outward, this one is radially inwards. And here electric field direction of two equal and opposite charges is from positive to negative charge direction. This is same like magnetic field. In class 10 you studied already that about magnetic field. You draw the magnetic field lines with the two poles, north and south poles. If you draw the magnetic field lines from south to north, always the magnetic force traveling towards north. Here it is electric field, the traveling from positive to negative direction. This is about electric field and direction. Now the electric field strength. What do you mean by electric field strength, or how you define the electric field strength? Which is defined as the force per unit positive charge. And here it is, an equation is showing E is equal to F divided by Q, that force divided by charge. E is a vector quantity, it has both magnitude and direction. The electric field, it has both magnitude and direction, so it's a vector quantity. And for radial field, you have to combining this equation with the Coulomb's law. I think, did you remember the Coulomb's law? The Coulomb's law states that the force between 2 point charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between their centers. You wrote that equation F proportional to Q1 Q2 by R squared. For changing the proportionality sign, we have to write F is equal to K Q1 Q2 by R squared, and K is the Coulomb's constant, and the value of K also, I think you remember, 9 multiply 10 to the power 9 Newton meter square per Coulomb square. That is about Coulomb's law. But here also the electric field strength we are combining with the Coulomb's law. We have to rearrange the equation E is equal to K Q by R squared. If I give you some problems to solving, you have to use this equation for finding electric field strength. And one more thing we have to say, what about the strong and weak field? Here it is the space between the strength, showing the space between the line indicate the strength of the field. The stronger the field would have more closely spaced lines. But this is more closely spaced line. This is that much not closely. So this one is the stronger field and this one is weaker field. This is equal and opposite charges have field lines like this. So remember that the space between the line indicate the strength of the field. A stronger field would have more closely spaced lines. Electric field strength is defined as the force per unit positive charge. And remember the equation also. Now electric field line pattern. The electric dipole consists of two equal and opposite point charges. The number of field lines leaving the positive charge is equal to the number of lines terminating on the negative charges, because it is equal and opposite. The magnitude is equal magnitude. Both the point charges have equal magnitude. And there is opposite charges. Here it is, see the like charges, it repel each other. For equal but like point charges at a great distance from the charges, the field would have approximately that of a single charge. So it repel each other. This is the field pattern about opposite charges and like charges. Now what do you mean by electric potential? Electric potential is defined as, it is at a point that the work done per unit positive charge. Electric potential is defined as the work done per unit positive charge in bringing a small test charge from infinity to that point. Here the picture showing this is Q, a point charge, but this is the point. Considering this point, we have to find the electric potential. At any point around a point charge, the electric potential is given by V equal KQ by R. And K is the Coulomb's constant, but Q the point charge, R the distance between the charge and the point. According to this formula, we have to say that the electric potential at infinity is 0. So, I think you remember that, you understand that electric potential is the work done per unit positive charge in bringing a small test charge from infinity to that point. And remember this equation also. Now comparing gravitational and electric field. Gravitational field is about the mass of the object and the electric field is about the charge. The gravitational field, that is inverse square law, electric field also inverse square law. That gravitational field, it is telling that F is equal to G m1 m2 by r squared. But that represent force, gravitational force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. The capital G represent the universal gravitational constant. And here it is also, we have to say inverse square law. This is the electric field is the force of that electric field, the 2 points are the force of a 2 points, and that is it states that the force is directly proportional to the product of their charges and inversely proportional to the square of the distance. Instead of this 4 pi epsilon square, we have to write K. Electric field, the Coulomb's law, we have to write F is equal to K Q1 Q2 by R squared. And next one is field strength. Field strength is force per unit mass. In electric field strength, force per unit charge. In gravity potential, it is scalar, and we have to write in the radial field V is equal to Gm by R. Here it is electric potential, V is equal to KQ by R, or we have to write Q 4 pi epsilon 0 by R. And field strength is, that's a potential gradient, gravitational field strength, and here it is electrical field strength. That is E is equal to change in potential divided by change in distance. And potential, gravitational potential is the work done in bringing a unit mass from infinity to that point. Electric potential, the work done in bringing a unit charge from infinity to that point. And equation for potential energy, here it is energy is equal to W is equal to mass into gravitational potential. Here it is potential energy in the electric field is equal to charge into electric potential. But this is comparing gravitational and electric field. But this gravitational field, it is about the mass, and electric field, it is about the charges. And gravity, you know that it is a force caused by weight is a force caused by gravity. It is about the mass of the object, and the electric field, this is about the charge of the object. Now, what do you mean by uniform electric field? In a uniform electric field, the field strength is same at every point, and the field lines are parallel and evenly spaced. This picture also showing that one, the field lines are parallel and each parallel is equal distance and between them. So here we have to write electric field strength is directly proportional to the voltage of the plates and inversely proportional to the separation between them. From that we have to write F by Q is equal to V by D, and last the final equation we have to write F is equal to QV divided by D. But this is about uniform electric field. All these equations we have to apply in the sums. Remember all this equation and the laws. Okay, I think all of you understand well. We will do some solving problems and then you can understand clearly.